In this video, we're going to be taking a look at questions where you have to be able to identify the acid-base conjugate pairs. Before we do that, let's rewind to the beginning of the section where we have to look at and understand the definition of an acid and a base. So the definition that we're going to be interested in is the Lowry-Bronsted definition of an acid and a base. According to the definition, an acid is a proton donor. Now, a proton in this section is an H plus ion. And a base, according to this definition, is a proton acceptor. Now, let's take a look at what this means using a simple reaction. So you have H2O plus NH3. That's going to give you NH4 plus and OH minus. Now, to figure out what the acid and the base is, before we actually figure out the conjugate pairs, we need to look at the definition. Remember, an acid is a proton donor. So suppose I focus on the H2O. What I actually need to do is, I need to look at my products and try to figure out what did the H2O turn to or become. Now, if that's a bit difficult, maybe we can look at the NH3 first. It doesn't matter which one you do first, because then by process of elimination, one will be the acid and then the other will be the base. But seeing as we're starting with the H2O, I can see that the H2O became OH minus. So these two would go together. I'm going to highlight them using the same color. Let's just go with blue here and blue here. Next, I can, then by process of elimination, the NH3 would pair up with the NH4 plus. So now what we've done is, we've got our pairs, but we just need to figure out now what's the acid and what's the base. So if I focus on the H2O, I can see that the H2O lost one H plus. It lost an H plus. So lost an H plus. Now, losing an H plus is the same thing as donating an H plus. So in this case, the H2O is going to be my acid. That means the NH3 must be the base. Now, what does the acid turn to? So H2O and OH minus. If the H2O is the acid, that means the OH minus is called the conjugate base. And if NH3 is the base, it means that NH4 is going to be the conjugate acid. And this is what we refer to as our conjugate acid-base pairs. Let's do some examples and we'll apply what we've learned to these problems. So this question says, number one, identify the acid-base conjugate, the acid-base, conjugate acid and conjugate base for each of the following. So A, HClO4 plus H2O gives you H3O plus ClO4 minus. Now, I'm going to apply my rules here. I'm going to highlight the HClO4 and I'm going to figure out what did that turn to or become on my product side. So I can clearly see that ClO4 is similar, so I'm going to go with this. So that's going to be my pair. Next, that means the H2O will pair up with the H3O plus. Now I need to figure out what happened to each thing. So I can see that the HClO4 became ClO4 minus. So what's different? The ClO4 minus doesn't have a hydrogen. So there was a loss or donating of a hydrogen or an H plus, a proton. So that means the HClO4 must be my acid, because according to the definition, an acid is a proton donor. That means this will be my conjugate base. That means in this case, the H2O is going to be the base and the H3O plus is going to be my conjugate acid. I'm just going to write it as Ca and Cb. Let's take a look at the second one. So H2SO3 plus H2O goes to H3O plus and HSO3 minus. So again, I'm going to highlight my pairs. So H2SO3, and then I can see HSO3. So those would go together. Then H2O and H3O plus. Now I can see again that H2SO4, to become HSO3, it must have lost or donated a proton. So that must mean H2SO4 is my acid. That means HSO3 is my conjugate base. That means H2O must be my base and H3O plus must be my conjugate acid. Now, by now, most of you would have recognized that there is somewhat of a similarity now between your acid and your conjugate base and your base and your conjugate acid. So, for instance, let's look at B. If I write down my acid and my conjugate base, my acid was H2SO4, my conjugate base rather was HSO3 minus. Then, if I write down my base is H2O. Let me write base first. And my conjugate acid is H3O plus. So what do we notice? So immediately you'll notice that the conjugate base has one less hydrogen than the acid. So the conjugate base has one less H plus than the acid. And then if you look at the conjugate acid, what do you notice? It has one more H plus than the base. And that's what we're talking about. There's a transfer of your protons. Let's look at C. So here you have C2H3O2 plus H2O giving you H3O plus and then C2H3O2 minus. Now by now, since we kind of have the gist of it, you can see that this would have donated a hydrogen to become this. So this would be your acid. This is going to be your conjugate base. Then this is going to be your base. This is going to be your conjugate acid. Next, H2S plus H2O. You can see again, H2S becoming HS minus. There's one less hydrogen here. So this will be your acid. This will be the conjugate base. That means H2O will be the base and H3O plus will be your conjugate acid. Now let's take a look at the next one, E. So E, you have HSO3 minus plus H2O. Then you have H3O plus and then SO3 2 minus. Now again, if you look at this, HSO3 minus and SO3 2 minus, there's one less hydrogen here. So that means this must be the acid. This must be the conjugate base. That means H2O will be the base. And this will be your conjugate acid. Let's take a look at the next one. NH3 plus H2O. So NH3 becomes NH4 plus. H2O becomes OH minus. So NH3 goes to NH4 plus. It didn't give a proton, it gained a proton. So it gained one. And what species gains? According to the definition, a base will gain a proton. So this is going to be my base. That's going to be my conjugate acid. That means in this scenario, H2O is going to be an acid, and this is going to be my conjugate base. Notice in these examples, H2O can act both as an acid and a base. So a species that can do that, or a compound that can do that, is called an ampholyte. Anyway, let's look at the next one, HF. So HF becomes F minus. Quite clearly, we can see that there's been a loss of a proton. So that must mean that HF must be my acid. F minus must be my conjugate base. Then HSO3 minus must be my base. and H2SO3 must be my conjugate acid. Now, this is an interesting one because HSO3, notice in one question it acted as an acid, and in this one it's acting as a base. It can do that because it has the capacity to donate a proton, and it can also accept a proton. So that's also an amphelite. And then let's look at the last one. You have HNO2 becoming NO2 minus, and then you have HS minus becoming H2S. Now let's figure out what happened. So HNO2 became NO2 minus. It lost a proton, which means that HNO2 must be my acid, and this must be my conjugate base. HS minus then by process of elimination will be my base, and this will be my conjugate acid. Thanks everyone for watching. I hope you found this useful. Don't forget to like, share, and subscribe. I'll see you in the next one. Bye-bye.